Hi, my name is Xin An, and I am in Greco's class P04. This is the midterm 2 exam wrapper, and I did question 2. So here's the problem. A long thin metal wire with radius r and length L is surrounded by a concentric long narrow metal tube of radius r. Insulating spokes hold the wire in the center of the tube and prevent electrical contact between the wire and the tube. A power supply is constructed with the device as shown. A power supply maintains a charge of plus Q on the inner wire and minus Q on the outer tube. Like a spherical metal shell, the field produced by the cylindrical metal tube is zero at every point inside the tube. Determine the potential difference between the inner wire and the outer tube. Be sure to show your work and check the sign of your answer. So as you can see on your right hand side, that is the picture of the tube, and we're supposed to find the voltage difference between the tube and the wire. So here's exactly how I did it. The first step is that I modeled, I wrote down the question, or what we're trying to find, which is V tube minus V wire is equal to delta V. That's our voltage difference. In the second step, you know that the general equation for voltage difference is delta V is equal to the negative integral from A to B of electric field times the delta X, And so in this case, our electric field is, we're going to use the electric field of a rod equation, and we're going to go from the little r to the little r of the tube within the cylindrical tube to the radius, the big R, which is the radius of the big cylindrical tube. And so when we set up our equation, we get the negative integral from small r to big R, and then that's all our electric field equation times dr. And then if we can pull out the constant, which is 2q over L over 4 pi epsilon naught, and then we are left with the integral r to r 1 over r dr. So after we simplify that and we take the integral, we know that the integral of 1 over r is ln of r. And so since it's from small r to big R, after we simplify it, we pull out the constant, and we're left with ln of big R minus ln of little r. And that's it.